So my name is Eric Cho. I'm super excited that you guys are here to share a little bit about my talk. So I'm part of the A10 security research team, and our main focus is really doing DDoS-focused threat intel. So our title is really DDoS mitigation with Ansible, TPS, and FastNetMon. So just a quick show of hands, like how many people have heard of A10 TPS and work with TPS? Okay, what about FastNetMon? And Ansible? Okay, cool. So just in very short, so TPS is obviously A10's platform for DDoS mitigation, whether it's on-prem or in the cloud. And Ansible is an infrastructure automation tool that's not just for networking, but also servers and infrastructure in general. And the FastNetMon is actually a DDoS detector that is open sourced and is able to detect anomalies for traffic patterns based on NetFlow and SFlow and V5, V9, so on. I picked these two, but the main objective really is that A10 works well with partners. You can see a list of partners on the side there. I picked these two because they're open source and they're free to try, and you guys could download after this talk and try it out really quickly without any cost. So of course, I'm the one standing up here, but this is obviously a team effort. We have a team of researchers as well as developers who's developing our platform. So these are some of the examples. This was at O'Reilly Velocity that we have the talk, and obviously you saw the book, which is free for download, as well as a physical copy here. And this is one of our Kibana threat map display here. Let's do a little overview. So unless you live under a rock for the past few years, you've seen the DDoS attack that's been happening. So 2016, we saw Oracle dying, that's going down, that's big news. In 2017, we saw GitHub that went down. So it's actually increased in volume. It's the cost of launching the attack has gone down dramatically. And with the increase of IoT devices as well as vulnerable weaponized computers, it's just gonna increase. So essentially, in one word, it's just gonna getting easier and easier to launch DDoS attacks. The barrier for that attack is just super easy nowadays. So the weapons typically is vulnerable hosts. So maybe don't click on that Taylor Swift video when you get that in the email, and may not be a good idea. But just people careless sometimes and become weaponized as far as the IoT device as well as their own host. So obviously we gather X amount of type of DDoS attack and there are different vulnerabilities. But if there's one thing that I could tell you guys, that the main point for DDoS attack is really this amplification factor, is that I'm Eric and you're David. So what I could do is I could spoof and tell the botnets and say, hey, I am David, I'm sending a small request, and through these botnets that I'm able to disrupt your traffic because I'm sending a request, say it's NTP. I'll say, hey, show me a list of NTP, which is a very, very small request. But when the NTP list of open NTP servers get responded, they responded to David. And therefore, that's a lot more packets, and each packet is a lot more in size. And that's the implication factor. So I am easily launching that attack by sending a small request and through the vulnerabilities to each of these vulnerabilities and to stop the traffic from going to David's site. And that is really the main thing. So because the botnet is at the central of your DDoS attack, imagine if you have a way to actually know in advance of time who these hosts are, and then you could stop them upstream. And that is essentially what we've been doing, is that we proactively go out and find out which hosts are vulnerable. And we know the location, we know the organization that they belong in, we know the country that they belong in, and therefore in advance, we could actually pre-populate this list and stop them from upstream. Say, if you're a company that doesn't do any business with, I don't know, Russia, I mean, there's no need to actually allow traffic in from Russia, especially the amount of compromised hosts that's already in that region. So these are the work that we put in, and if you guys go to the back corner, you can actually see this is static, but we actually have an interactive map that displays. You could filter by vulnerability. I believe you can also filter by country, and you can filter based on the type of vulnerabilities that you see right there. And of course, The front end is what we choose to display in. It's pretty to look at. Obviously, we have the data, and we could organize it however we want, including working with TPS to integrate into our DDoS mitigation ahead of time. So this is our Kibana dashboard that displays it in just another way that we choose to organize it. So if there's any key points, so the attacks that keep on happening and the vulnerability are different. So the key points really is to be agile, to do it in advance, and to not be so reactive. At the time of attack, that's the worst time to think about mitigation strategy. So A10 really has the TPS advantage. What some of our advantages are is that we have API and our code is on parity. So everything you could do in our CLI, you can actually do it automatically through API. We are both in the cloud as well as on-premise. So we sell physical hardware as well as virtualized appliance. We have a proven track record. There's a list of logos that you guys can look at and use cases such as Raphael. If you guys were here for the previous presentation, they actually have the TPS in production, protecting their customer. And of course, this is near dear to my heart. We continuously trying to improve, so you guys don't have to. We do the dirty work, we do the legwork on dealing with these botnets, so that we could present it to you in a useful and actionable way. So these are just a partial list of our partners. I want to let you guys know that one of the main objectives for A10 is actually we want to be open to the whole ecosystem. We play well with our partners. We're open and we use standardized APIs that, so a lot of these people are our partners. If I may be honest, we can't say the same thing about every player in this industry. So I picked two players in particular because these two are open source. This is the FastNetMon. We're a partner with FastNetMon, and we're also a partner with Ansible. So if you use Ansible, if you use FastNetMon, it's a really easy onboarding. But I'm going to show you a quick demo that if you're not a customer of, or if you're not using Ansible, say you're using Terraform, you're using Puppet, Chef, that's okay too. A10 has an open API that could directly work with most of the tools out there. You can even write your tool like what I have right here. And it has more in-depth analysis on the site so that you could do it at your own time and have a more in-depth reading. Okay, cool. So essentially, this is a 3030 platform that currently you can see there's no protective object. Essentially, awesome. So there's no protective object. The way that we onboard the DDoS mitigation is using our API to create, upon detection, that create the protected object so that and using BGP advertisement to route the traffic toward the A10 device and mitigate it. So that was our GUI, and you can see there's no protected object at the time. We use FastNetMon, the open source DDoS detector, to detect the anomaly. And so we're using that particular script, which is also, you could see on our GitHub site, that you could use it, if you like, for testing. So I artificially lower the detection limit. So you can see that the traffic that's going, we use the HP3 for the flood attack to simulate the flood attack. And now you can see that because of the increased anomaly, that the traffic, the IP, destination IP, now it's being banned. And now we see the protection object that's being created on demand without human interaction. And the previous BGP routes was 5, so now we're advertising this particular one that's being banned to route the traffic to the A10 TPS device so that we could start scrubbing. And if you look at our GUI, this is slightly outdated, so we have a prettier GUI now, but if you refresh it, because this is a test device, you could clearly see the ramp up in the CPU and the memory footprint. So now that we're going to stop the attack, and stopping the attack, you could see in a minute that the protected object is going to just automatically gets deleted. So no longer there's a protected object. And for the BGP, it's off ramp. So now, no protected object. The entry is now removed. and the BGP prefixes. So now the traffic is back to the normal path as opposed to going through A10. And if I refresh our GUI, there's no longer, the object is no longer there. So everything is automatic, say if it's, from Raphael's talk. Yep, for Raphael's talk, if it, 2 a.m. in the morning, nobody's getting noticed. So next morning he comes in, everything happened automatically. So, which is great. So I want to thank you guys for spending the time, and I hope you win our power bank.